What is up, everyone? Hey, first of all, thank you for all those new subscribers. I truly do appreciate it. It incentivizes me to go out and make additional videos focused in on large language models. So huge thank you, much appreciated. And for that, I wanted to do something where we're going to dive into how traditionally large language models were trained and how DeepSeek approached training their model based upon the paper that they provided or published here recently. And so I really want to do a deep dive showing what the differences are, where they're being able to utilize or implement some cost efficiencies relative to what's going on through the traditional pipeline process. So on the screen you see here is the traditional pipeline process, where we're going to have this pre-training stage where we generate our base model. It's basically scraping data, providing data, all that stuff coming to the base LLM model, as we'll call it. This is what everyone does, and this is what DeepSeek has done as well in their R10 model, and that's the particular model we're going to be discussing today. Where things begin to deviate is going to be with this supervised fine-tuning and RL training model itself. And so we're going to go into, again, what their traditional model is, in that it implements traditional LLM models. We take that base model and we're going to send it into the supervised fine-tuning model. And I have another slide that's going to discuss that a little bit more. But it's basically what we're going to refer to as supervised learning. You're going to have some human written examples where you provide maybe the questions and then the answers. And so you're going to be providing it questions and then the answer set together so it knows and can continue to train and provide a little bit of inference and maybe contextual analysis, that piece of it, or that's what I'll call it. And then it goes from that supervised fine-tuning model into the RL training model. And one thing I want to say is that traditionally in the RL training, as described within the paper, they have been using neural networks to calculate the rewards. And so while DeepSeek is also using RL training, it's using it in a little bit different way. But let's hit on what some of these other blocks are in a little bit more of a simplified manner. So here we have the pre-training step, and that's that base model, where it's going to take something along the lines of the quick brown fox jumps over the lazy dog, and it's going to mask out those portions, and the base LLM model is expected to provide maybe the tokens or the words in place of what those masked out portions are. And so once it's able to do that, that's going to be the base model. It then takes that base model moving into the supervised fine-tuning, where it's going to ask the human maybe inputs, explain atoms, and it's going to go through that supervised training process of explaining what atoms are and going through that question and answer bank and so forth. And then again, we have our RL training piece of it there, where you're going to be providing rewards based upon which response is better. So sometimes we might see that in the ChatGPT. When we put in query, it'll say which response do you prefer better. It's going in and calculating which one we have. But in this instance, it's the neural network that's actually generating the rewards based upon that and feeding it back to further train what's expected of it. So now we're jumping into that different piece. If we go back again, the DeepSeek base model or the base model is the same in all these instances, where everything's changing based upon the DeepSeek R1-0 model is right here. We take the base model and we're cutting everything off and removing, deleting it. So this is arguably what's going to be used to generate the cost savings and so forth, and in the different ways that they're doing. So here again, well, here's that base model. Here's everything, and now it's actually going to be utilizing something, and we're not going to be jumping into the exacts of it within this model, but what it's referring to is basically, and I have it written down here, so the GRPO policy that is an in-house piece of it. Now, I want to stress here that it talks about it. It's an in-house group relative policy optimization that everything gets fed into. So traditionally, as I mentioned before, there's the neural network reward model, and there's not a critic model which saves computing based upon that. Instead, the RL here is a rule-based reward system that focuses in on accuracy rewards and format rewards that we see here. So it's going to have example tasks that it's generated that are both, for instance, in this, math problems, and then leak code problems, which are just computer science problems generated with a compiler, so that math and code, if we want to be thinking about it, those have accurate, or they have answers that are correct and can be checked by through the thought process. What we'll go through a little bit more here, but basically there's going to be an accurate answer based upon something of providing an example task, such as, let me know what the x is in the following equation, which we'll show here. And then it provides, so we have the accuracy rewards, and then we have the format rewards, which get fed into the rules-based reward system by first showing your format, or showing your work, as I'll kind of call it, and then we have the accuracy rewards of, are you accurate? So let's take this example of what the reward structure is. On the left here you see, let's solve for 3x plus 5 equals 14. So that is going to be referred to as, the accuracy is, hey, is this, what's the result? Is the answer this? And is it verified? But we have to go back and think about that format as well. And the format, if you go back and check out that video in the relation of a llama, the question that I posed to it was, how would you approach C++ object-oriented programming, or something to that? C is the think tag, and it'll go through and say something along the lines of, if I'm doing object-oriented programming, C++, I'm going to have to learn about inheritance, polymorphism, classes, objects, methods, all these different things that, and it's basically showing its work. And so the format reward is, are you showing your work? And then the accuracy reward is, did I get the answer correct, or did it get the answer correct? And so we see this, and that the model response should be, here's how I thought about it, and here's me showing my work, and finally my accuracy. Both of those are checked, and you get rewarded and basically optimized through that. And so that was the iterative approach that they took. And again, I'll stress here that this is only with regards to the DeepSeek R10 ways that they trained their model in the next video. So make sure to hit subscribe if you want to see that. But anyways, I just wanted to do a dive into that first part of the paper and where it deviates and how it is, and a simplified way of doing it. So thank you, and until next time, have a great day.